Okay, so we're trying this. For the first one, we want to remember that an exponential function is of the form a to the bx. Number 1 is a linear function, number 2 is a power function, number 3 is a parabola, number 4, so only number 3 works. For number 2, we're going after the 1/2, then x is equal to 1/2. So we'll have after the 1/2 will equal 6 times 9 to 1/2, which is equal to 6 times 3, which gives us 18. So it's number 2. This is a composition of functions. So first we're going to find g of 2, which will equal 5 times 2 minus 7, so that's 3. And then h of 3, which will equal 3 to the power of 3, which is 27. That gives us 4. Number 4. So this graph is an exponential function graph. So of these, only options 2 and 4 are possibilities. Now, option 4 is an increasing graph. As x gets bigger, y gets bigger. So only option 2 will function for us. Lastly, question 5, we have an exponential graph, again. All of these are exponential graphs, 1, 2, 3, and 4. So now if we're looking at these, we have a y-intercept at 3. So when x is 0, y is equal to 3. And the only one that's going to work for, actually that'll work for 2 of these. It'll work for number 3 and for number 4. However, number 3 is a decreasing function. Number 4 is an increasing function. So only number 4 satisfies our requirements. Sketching these graphs. Looking at option A, we can tell that it's a decreasing function because the b value, this piece right here, is less than 1. So I'm going to plot a few values here. When x equals 0, y is going to equal to 18 times 1. So that'll be 18. When x equals 1, however, y will equal 18 to the 1/3, or 18 times 1/3, and that's 18 divided by 3, and that's 6. Let's pick another number when x equals minus 1. It'll be 18 times 1/3 to the minus 1. 1/3 to the minus 1, which is the same as 18 times 3, which is a lot, not quite 60. So if I plot this right here, let's go from minus 1 and 1. When x equals 0, it's 18. Let's say that's 18. When x equals 1, y is equal to 6, ballpark. And at 1, it's huge, so my graph is going down like this. My second one, when x is equal to 0, I've got 25 times 4 to the 0, which is 25. This is very big and massive. This should be an increasing graph, by the way. When x is equal to 1, it'll be 25 times 4 to the 1, which will be 100. That's huge. So 1 will be way big. And when x is equal to minus 1, I'll have 25 times 4 to the minus 1, which is equal to 25 over 4, which is not quite 6. So let's imagine this graph generally increases rather largely. Now we move on to number 7. And number 7 is a word problem. All right. So this is telling us about a cup of coffee. All right, I like coffee. It starts at a temperature of 185 Fahrenheit, which is in Celsius, I don't know, but it's hot. That's our function. There's a rate at which coffee cools down over a period of minutes right here. So when we have f of 60, what that tells us is when 60 minutes have gone by. So 60 minutes, it's been cooling for 60 minutes. So 60 minutes after I make it, it tells me that the temperature is equal to 86 degrees. So if I wait 1 hour after I produce a really hot pot of coffee, it'll still be 86 degrees Fahrenheit, which actually is just kind of warm. The temperature of the coffee after 1 day. So my function was in minutes, so I need to get 1 day in terms of minutes. So 1 day is equal to 24 hours, which is equal to 24 times 60 minutes, which is a lot of minutes. So 2 times 60 is 12. 20 times 120, 1200 plus 240, 1440 minutes. Well, now if I plug in 1440 into my function, this is my function right here, it's going to be very large, and I'll need a calculator. What you end up with should be, however, because the function is decreasing, a very small number. As we all expect, my cup of coffee should just be cold after one day. So you'll plug this into your calculator and get a number. Now at a reasoning question. This one's a bit of a toughie. What we have here is two exponential functions. We don't know much about them. We do know. Okay, so this one, let me get a pen right here. This function is increasing, this function is decreasing. So for this one, d is greater than 1. And for this one, d is less than 1. So they're not the same. Now, a and c can't be the same because the y-intercept is not the same at 0. If you look here, for c, the y-intercept is here. For a, it's right there. It's a little messy, so let me try and explain this. At 0, if a and c were the same, you would have a, b to the 0 is equal to a, and c, d to the 0 is equal to c. If a and c were equal, they would have the same y-intercept. But since the functions don't have the same y-intercept, a and c are not equal. A and p can be the same. First of all, they're the only choice left. And secondly, I can just imagine this. Doesn't mean it's necessarily the correct one. We don't have any values here. But it's definitely possible for a and b to be the same value.